So practice problem number 5. Data concerning the changes in concentration of a single reaction A is in a particular chemical reaction are collected and tabulated below. And that's great, but it's kind of hard to read tables, and so maybe they're going to give you a graph. So you see that they graph the concentration versus the time. If this was a straight line, it'd be 0 order, but it's not a straight line. We look and we see that ln of A versus time is linear. So if you can't remember what that is, you go back to your kinetic sheet. It's the first one on the kinetic sheet, so this is first order with respect to A. What is the order of the reaction with respect to A? Hey, we just answered that. It is first order because ln of A versus time is a straight line. So the next question they ask is they want to know the half-life. Since it's first order, we know that it's going to be constant. It's going to be a constant, so it's always going to be the same. So I might go back to this first graph because it's easier to look at. I started off with a concentration of 1, and I want to figure out when it's going to get to 0.5. That looks like about 7 seconds. And then I got 0.5, and I'm going to figure out when it's about 0.25. It's about there, so it's about 7 seconds. So that's the graph I want to look at, is because I want to see when the concentration halves. So a little over 5 seconds, so I would say. Calculate the rate constants for the reaction. So I might go back to this graph. I'm going to find the slope, because the slope is going to give me the absolute value of K. So I need 2 points. Hey, 0, 0 is a nice point. And 25, negative 2.5 is a nice point. I get negative 2.5 minus 0. Wow, that's horrible writing. Negative 2.5 minus 0 over 25 minus 0. That's going to give me a slope of negative 0.10. And we know that K is negative, the slope for first order, so I take the absolute value and I get